and gentlemen. My name is Roman Jaroszewski. I represent Mitsui Chemicals, a Japanese producer of raw materials. I represent the European group of that. Before I come to my presentation, I would like to express my sincere gratitude to all those people who prepared this event. I have a chance to learn in the last 2 days, to learn a lot about the Eastern African market. So thank you very much. What I'm going to talk about today is what, why, and where regarding to our product Admer. And first question is what it is. Admer is a self-introduction of Admer. As you can see, Admer is an adhesive polymer. And in the booklet which you have with the program, there is mentioned Admer team. It is just TM is a trademark. So the proper name of the product is Admer. What is Admer? Admer is just a grafted polymer. We take a polyolefin chain and we graft on the polyolefin or the modified polyolefin chain. We put a reactive group like you see here. And what is the function of this? Why we do it? When I start to talk about the function of a tie layer, I have to start to talk about what is packaging. You heard about the barrier properties to prevent the wasting of the food. You have to put a barrier, oxygen barrier. My colleague from Kuwarai will have William will have another explanation, detailed explanation about that. But the packaging is not only the barrier, not a gas barrier. The packaging itself is a separation of the product from the environmental influence. And what can destroy the food? Food can be destroyed by exchange of the water, by drying, for example, can be destroyed by the oxygen influence and by light. For example, milk products are very sensitive to the light. So to prevent the wasting of the food, you need to put the oxygen barrier, you need to put the moisture barrier. From the chemical point of view, both materials, they cannot stick to each other. So for that, you need something special. You need a tie layer in the middle, which brings the two materials adhere to both materials. And of course, this is nothing special that adhesive should adhere. That is not what will surprise you. But this adhesive can have another function. For example, if you have a multi-layer structure for thermoforming, and if you will put very thick layer of a polyamide and you will try to shape it, you will have a big changing of the thickness. It means you will influence the barrier properties of this material. To avoid this, you can simply split the polyamide and put the tie layer in between. When you shape it, the layer will slide on each other and will give you possibility to keep the thickness in the better way. Additionally to that, you can use a tie layer as a skin layer if you want to, for example, to seal or to laminate this multi-layer structure on aluminum. You can make it with the hot rolls. You have a lot of possibilities to laminate it on aluminum, for example, on the metals, to improve the barrier properties. We know that, for example, aluminum is a perfect barrier against moisture, against gas. But aluminum has one disadvantage. If you fold it, it can break, and you can get micro cracks. And with the barrier, it's like with rubber shoes. You have one small hole and a wet feet. So exactly the same you have with aluminum. If you fold it and you have a micro cracks, the product will be destroyed. Okay, so let's go further. You can use, as you see here, tie layer or adhesive to extend the functionality of your structure. The next function of a tie layer in the structure can be explained on the sample of in this way. If you think about two bricks and you put concrete in between and you move it, what did I do? Excuse me? Oh. And if you move it, it will simply break. If you put rubber in between and you move it, it will be much more flexible. The rubber will absorb the energy which you create during the movement of the layers to each other. Yeah? This is what the tie layer is doing. And you see that the more tie layer you have in the middle, the more you can move the layers. I will talk later about the necessary thickness of the tie layer in the structure. So ADMR serves as a buffer zone in the normal multi-layer structures. This is usually the most elastic part of the structure. If you take the polyamide is very stiff. If you take EVOH, it's much stiffer than the tie layer. And you have to combine it with, for example, stiff HDPE. And the tie layer will allow you to move the layers. So what I want to say that the tie layer, if you think about a tie layer, you can imagine the spring with two hooks. The hook is a bonding, and the spring is just a cohesion of the material. So what the tie layer is doing in the structure is simply that. Now let me come to the processing, to the structure and processing. In your equipment, if you have a multi-layer equipment, you will put polyolefins. Polyolefins are usually the carrier of a structure, and at the same moment, they are giving you the moisture, perfect moisture barrier for the products. On the other hand, you have barrier materials like EVOH, like polyamide. This is a red one. And in the middle, you have a tie layer, you have an ADMR. This ADMR has a physical bonding to the polyolefins and a chemical bonding to the barrier material. And how does it look with the chemical bonding? This is a chain, polyolefin chain with a maleic anhydride group, a reactive group, which we use for the tie layer. And this is, let's move. This is the EVOH chain with the OH group on the end. If you bring the heat, the bond between the oxygen and carbon will break and will just give you the bonding between the EVOH and the polyolefin chain. The same you will have with a similar, you will have a polyamide. And you see that the polyamide bonding have an additional part, which is on the top. And therefore, the bonding to polyamide is something like 20% stronger than the bonding to EVOH. I've been talking already about the adhesion to aluminum. It looks like this. And I have to admit that there is no adhesion to metal at all. There is always adhesion to the oxidation layer, oxidated layer on the top of the aluminum. Okay. Now, let's come to the question where you can find this product. I would say the answer is you can find it almost everywhere. If you look at this is Bexinbock for wine. I don't want to say that there is ADMR in wine. You will find ADMR in the packaging, and we have a very good food-approved product which will not migrate to the wine. So the product will be only in the valve, and our tie layer will be in the bag, wine bag. Final application, you will find Admer in the product like aluminum foil, like cartons, like bottles, tubes. And when we are talking about the tubes, tube can be laminated tube. It's what you know from the toothpaste, or cosmetic tube, which is more or less produced as a pipe. Cosmetic tubes are always very complicated. They have a very special softness. I don't know, I can just tell you a small funny story about the surface of a tube, cosmetic tube. The producer of a tube wanted to make it attractive for the ladies. And what is the most attractive for the ladies? Children. So they simply took, they tried to animate, to try to copy the skin of a child. And if you take the very high sophisticated tubes, they have a so-called skin touch, and it is a touch of a child's skin. You will find our product in the thermoform sheet. You know, there's a trace. You can have a mono trace, but for the high sophisticated, for the sensitive product, you use always a trace with the barrier properties. And the films, different type of the films, blow film and cast film. And the films can be used for many, many applications. So typical is a flow pack, where you can pack products like, especially like sausages, like cakes. There are ice creams in this type of a packaging. You can find it in the stunt pouch. You have a different type of these pouches. The typical one is dedicated to the wet products and the dry products. You can buy the salt in that, but nowadays you can buy the cosmetics, detergents, oil, everything would change to the pouches. It is the most convenient product and the less, waste-creating product. For the thermoformable trays, you have a typical trays which are for packaging of a processed meat, but you can have, for example, trays prepared for the ready food, which are sterilized, where you have more or less some kind of plate, you put the meat, potatoes, and whatever in it, and you sterilize it after the sealing. Now I talk about the thickness of the structures. Just to give you the certain image about the thickness of different structures, I put the most popular, like for example sausage casing. It is something what is in the range of between 40 and 50 microns. The shrink film is something between 50 and 100 microns. Lid film is usually typically 70, 80, but it can be thinner. Thermoformable film, it can be around 200, 250 microns, the total thickness. And the sheet is usually starting from 250 to 1 micron, to 1 millimeter. And you can find here the thickness of the tie layers in those structures. Usually we are talking about 2 to 10%. The thinner the structure, the higher the percentage. And you see that the typical casing would be something like 3 microns, 2.5, 3 microns. Sheet will be 5%, means something like 20, 25 microns. Bottles, the total bottle thickness is something like 500, 700 microns. Usually 20 to up to 50% is a tie layer. The thickness of the tie layer in the structure depends on the final use. Even if you have bottles, if you have squeeze bottles, you have to put more tie layer to make it more flexible. If you have, for example, the pesticides bottle, agriculture bottle, nobody squeeze it. It's very thick. The thickness of the tie layer is much thinner. Now, we have in our program, I don't want to show off, but we have 3,500 different recipes. And why we have so many? Because there are so many applications. What I would like to show you is a main group of the products or the applications which we have, and this is a bottle, and I'm talking only about the application for the food. We have an application related to the automotive for the plastic fuel tank, as it was mentioned this morning. We have a from construction for the pipe, but those are only applications related to the food. Bottle, sheet, blow film, cast film, and extrusion coating. You see that there is always a speed of a line mentioned below, and what you see here, those are the flow properties. Flow properties, melt flow rate of the product. What you see here, it's on the other side is adhesive performance. I'm technician, so I call it adhesive performance. My colleague from the sales would say it's a price. If you put our grades, you will find this picture in our brochures. We take it over. This is it's the explanation why we build it up like this. Now, please allow me to explain the nomenclature, the names of our products. The first two letters. The first letter is telling what is the polymer, the base polymer of the tile layer. Q means polypropylene, N means LLDPE. And I do not know why we choose the letters. I think just to confuse the competitors, to confuse our clients and to confuse our customers and confuse ourselves. I don't know, but it is like it is. The second letter is giving you some image about the application the product goes for, and the last letter is giving you the origin of the product. Since Mitsui Chemical, my company, divided the world in three parts, like an orange. So there is American part, there is Asian Pacific part, and there is Europe. And I have to say, you are Europe. Even if it's surprising for you, you are Europe. So you will be getting material coming from European production. And the number in the middle, it's so confidential that even I do not know what it means. Oh, sorry. This is a page from our brochure. I think my colleague already already gave you our brochure, so you have it. You can find a description of our grades. But if you need any information, any advice, how to use it, what to use, we are on the booth 21. Our colleague Joseph is located in Kenya and will be probably happy to support you with the information. This is a page with general recommendation for the temperature setting for our product, but it is only general recommendation. If you start to produce, we will be really happy to support you on that. This is a technical product. It's not like a commodity, like a polyolefin. You put it in and you run. The multi-layer structure is much, much complicated than a single monolayer structure. For that, you need, from in the beginning, definitely you need our technical support. And we will be really happy to support you. Thank you for your attention.